All right, here is the second part of 7.3. So we're continuing to practice and look for linear functions represented in tables. So let's check our input-output table, remembering that our inputs are our x's and our outputs are our y values. And when we are looking for a linear function, we have to have a constant rate of change. So the change in y over the change in x has to be consistent through the whole table. So let's look at just our first 2 points. An 8 to a 5, that's a decrease of 3. A negative 10 to a negative 5 in my inputs is an increase of 5. So let's see if this pattern continues. 5 to 2, that's a decrease of 3. Negative 5 to a 0 is an increase of 5. 2 to negative 1 is a decrease of 3. 0 to 5 is an increase of 5. Negative 1 to a negative 4, that's a decrease of 3. And 5 to 10 is an increase of 5. So we do see a constant rate of change. My y values continue to go down by 3, while my x values continue to go up by 5. So our rate of change is negative 3/5. So since I have a constant rate of change, I know it can't be letter D, so it could be A, B, or C. But the only answer choice that found the same rate of change as we did is letter A. So this is a linear function because the rate of change is 3/5. So sometimes you will use a table to make predictions. So we have a scuba diver problem that's going to help us look at the relationship between the weight of the water on the diver compared to the depth that they have gone down in the water. So in this table, we're going to see that the water pressure on the diver increases as the diver's depth increases. So for part A, they want to know what is the rate of change. So I need to find that change in y over the change in x and figure out what this represents in this situation. So let's look at our table again, knowing that my x's are my inputs and my y are my outputs. So here I'm looking at the change from 4.4 to 8.8, and I see that this is an increase of 4.4. In my x values, I am starting at 10 and ending at 20, so that's an increase of 10. So far my change in y is 4.4, my change in x is 10. Let's see if that continues. From 8.8 to 13.2, I know that that is an increase of 4.4. And in my x values, I've increased from 20 to 30. That's another increase of 10. My final 2 points to examine, from 13.2 to 17.6, I have increased 4.4, or 4 4/10. And in my x values, from 30 to 40, I've increased 10 feet. So my change in y over my change in x would be 4.4 over 10. So this is my constant rate of change, and this rate of change represents the water pressure that the diver experiences compared to the feet that the depth that the diver has experienced. So we have 4.4 pounds per square inch of water pressure for every 10 feet of depth on the dive. So what I'm going to be asked to do, beyond just determining that this is a linear function, is to now use this rate of change to predict the water pressure. So if I want to predict the water pressure on a diver at a depth of 60 feet and a depth of 100 feet, then I'm going to need to take and extend this pattern. So I'm going to continue adding 10 until I get to 60 feet so that I can extend this table. And then I can also continue extending until I get to 100 feet so I can make my second prediction as well. So now I'll continue adding 4 4/10 in my y values. All right, so as we take a second to extend our table here, we find that at a depth of 50 feet, the diver is going to experience 22 pounds per square inch of pressure, and we can continue extending this table to help us make some predictions. So at 60 feet, we would anticipate that diver to experience 26 4/10 pounds per square inch. And at 100 feet, we would expect that diver to experience 44 pounds of water pressure per square inch. So that's how we can use that rate of change in our table to make predictions. All right, last chance to practice to make sure you've got it. This table shows the age and the length of a shark over a 20-year period. What is the rate of change of this linear function? And what does the rate of change represent in this situation? So let's start here. I have my x values and my y values, and I'm looking for the change in y over the change in x. So as I look at my first 2 points, to get from 40 7/5 to 44 5/10, I see that this is an increase of 3 7/5. In my x values, I am increasing by 5. So let's check out the next 2 points in our table. We have 48 25/100, which is an increase again of 3 7/5 from our previous point. Our x values also continue to increase by 5. And finally, as I look at my last 2 points, my y values continue to increase by 3 7/5, and my x values continue to increase by 5. So my rate of change would be 3 7/5 over 5. And this rate of change represents 3 7/5 centimeters per 5 years. So now if I want to use this growth rate to predict the length of the shark when it's 25 years old and when it's 40 years old, then I just need to continue extending this pattern. So my x values are going to continue to increase by 5s, and my y values will also continue to increase by 5s. So as I continue my table and extend my pattern, I can see that when this shark is 25 years old, it is going to have a length of 55 7/5 centimeters. And when it's 40 years old, its length I would predict to be 67 centimeters. So you guys are all set to practice these skills on your homework tonight, which is Digits 7.3. So good luck, everybody.